Hello, thanks for tuning on lesson 13 of this first chapter of infrastructure security course. So this lesson is about endpoint. Let's review the syllabus. We are almost at the end of chapter 1 that brought all layers of the infra design. And obviously endpoint is playing a big role within the security strategy. And if you notice, the title for this session is Endpoint and Nonsense Dogma. And the nonsense dogma is because the industry on the endpoint security is a bit like a dog chasing his own tail. And this tail chasing is due to the fact that all conversation didn't involve too much, and the attack bypass are always about the same things. So let's start from the scope of analysis when you are defining an endpoint. First of all, you should define what is the endpoint in your own definition, because endpoint can be whatever device. So obviously, from an infrastructure design perspective, it can be extremely relevant your definition of endpoint. And so if you do consider and you analyze endpoint that are IoT based, you expect, for example, a design through an IoT gateway. So it's extremely important the definition of your endpoint analysis. Secondary, I see analysis on endpoint that actually focus and narrow the OS security. There is a level of trust across all devices from the booting. So there is the firmware, the protocols that are used to boot an emergency, for example, the last vulnerability of the Microsoft protocol. You do have a tons of layer that get involved. So when you define what is the endpoint analysis that you are trying to do, define what is the starting point of your analysis and what is the attack surface that you are trying to mitigate and analyze. That is extremely important because you see chunk of work that suppose trust of other layers, and you don't find that discussed enough. So let's, considering that, let's think about the fragmentation in endpoint. You do have a plethora of operating system that can run on the endpoint, and you do have kernel design that can be different, for example, in mobile, and the capabilities on the endpoint can be different too. For example, the IoT device that I was talking about. So when you have defined all of these, you need to think about the threat model of your endpoint. And so how get attacked, at which layer you are looking at. Because I see a lot of paper that don't forget that you can have an over secure endpoint, but the first things that the endpoint does when it gets switched on is to go and talk with the DHCP. And so for how secure it is, you have a trust on what you are getting from the DHCP. And you know that it does IP, it does DNS, it does a lot of things. So stop to narrow your vision and remember that whatever role you are having and whatever is the target of your infrastructure analysis, you need to be capable to zoom in, but to zoom out and see all components too. And that is a key skill that you should have. I see conversation that goes technically down, but forget the dependency with with system. Now with zero trust, we see a lot of attention into authentication as well. But if I have to attack a system, I'm not going to bother too much about your authentication authorization, I could play a bit smarter, hooking with beef the browser, stealing your session. So some of the analysis that you find out there are telling you that if you do identity right, you are okay. In the same way, the market is trying to stress you out that if you have an ADR, you are safe. It's not the case. It's not. So I give you a bit of history of how the evolution of endpoint in terms of security, how it moved, and I give you some example on how the industry tackled some challenges back in the days and how it's trying to tackle it now. And we will compare together how it's going. So the first time that PCI introduced the file integrity monitor requirement, you could witness a first assumption that all attacks were based on a file dropped on the file system, when actually there was already cases of memory memory execution. And so, I mean, you don't need a file to be dropped on a file system to have a problem and a payload running. So you'll see most of the time requirements that are based on assumption. The market is evolving and the solutions are becoming smarter, but the bypass are always the same. So if I take a picture of these 20 years of career, I hear the same conversation than 20 years ago sometimes. So there was a funny one that was quite common back in the days with the file integrity monitor. If you were having a file integrity monitor that was running in user space and somebody was choosing a solution like that, don't ask me why, if an attacker was writing a bash script with inside a command like an RM on NLS, on the log of a file integrity monitor, you could have been finding all this information of the name of a file of a bash script, but not what was running in, which process was running uh, under. So having a solution, a security solution that could have been the file integrity monitor, can be the audit D function, doesn't matter, is still a visibility problem. So having something that work on user space or in kernel space make a massive difference. User space can see the subcall to kernel. So you see the name of the file that get executed, but you don't find the command that get at kernel level injected. That is a simple example because there are tons of courses and you see the complexity of an attacking surface in terms of Windows API and whatever. I'm talking about something that is a general concept that you can apply to whatever OS. So user space and kernel space is a conversation that is extremely important for you to know and for you to understand. So at the time, we had a lot of security solutions that were running in user space. But running in user space was also silly because the attacker could stop it. It was a daemon, actually. And so at the end, you can stop a daemon. So this distinguish was the beginning of evolution of a bypass. Kill the security control, avoid the logging, but it was all local on the box itself. Now, today, we are running solutions that are having an high dependency on having the device online all the time. So that means that they expect a cloud elaboration of information, for example, hashes or whatever. Not everything happen obviously remotely. Some function happen locally, and we can't generalize too much. But there is for sure in the R&D of this solution, from a security standing point, we move from something that was poorly on the laptop, on the endpoint itself, on relying on some sort of connectivity. The attack surface didn't change and is still the same. You can have physical attack, you can have hijacking from a networking perspective, you can. So if you look at which kind of risk the endpoint is having, are actually the same. But the reply of the market was to be capable to track the processes. Now ADR is actually working like a malware and is hooking processes and checking the process flow of all. But that doesn't change the fact that there are tons of bypasses. This one is a nice article with some map of all. Sorry for scrolling. Is this URL that you see on top, and so I will not bother you because I, I'm trying to give you food for thought. But when you have an ADR, most of ADR bypass are based on the fact that anyway they load untrusted drivers. Each bypass can be different. It's still based on hooking. And there is a plethora of way to bypass an ADR. When you are doing an analysis on how you see the bypass, you are doing the right thing. And so the thinking on securing an endpoint is to have something that let you see what is going on, even if it gets bypassed. If you have some cloud service service that is anyway orchestrating your device or whatever, if a device is offline, it's starting to get tricky. And so you can find also some attack that put you offline. And we don't see much of research on that space too. So back in the days, everything was local. Now it's a bit less. And visibility is becoming a trust on the fact that everything gets sent out. What I do suggest is every time we do an analysis on endpoint, try to think with your own head and don't follow just the general talking. If you look at MitraTac, you look at all vendors' paper, you see researches, you see whatever, think in practical terms. Mas the ransomware, it was fileless, it was memory. It killed a lot of people. Why? Because people wasn't thinking out of the box on that space, in that. And actually it will happen more and more and more and more. And so we need to have visibility of endpoint. So first on your priority list, get visibility. How you can do it? OS query, Velociraptor, focus on forensics, have something forensics wise as well. It's quite good. When you are looking at all this stuff, you'll see how much you can see also the bypass of the solution that you're having. And we are not talking about cost here. We are talking about thinking. Because if you take a vanilla OS query, it can query whatever. If you look at the implementation with Wazoo, for example, you see how a diverse ecosystem can actually be monitored also for the bypasses. Now, it's critical. It's seriously critical because there is not much of thinking on that. And it's going to give a lot of problem, because if the industry after years and years is still struggling with command center, there is a lot of issues, because command and control are anyway something that Cobalt Strike was there for how long, and they are still crying on it. So let's be practical. Focus on visibility. Try to get a multi-stack. Focus on hardening. Look into OpenSCAP kind of projects. Be sure that there is the hardening. Hook all orchestrators. And I'm talking about SCM, Intune, whatever you use. And combine with an OS query. Whatever gets bypassed, you'll have evidence of that. But don't forget the exploitation on the browser side. That is the most underestimated things that is happening right now. So JavaScript is killing in terms of capabilities for malware. If you see keylogging, whatever can, the damage that can be done at the DOM is underestimated out there. So it doesn't matter if you really focus only on the OS, and anyway on the browser you don't have sandboxing, secure browsing, nothing. If you consider only integration of a module of ATR with your browser, you are really too optimistic, because whatever happens in the DOM, it's not going down to the OS stack. And the visibility of that, also in terms of obfuscation, is really high. And that's the reason why you still have trouble with command center, payloads, and everything. So think out of the box, use your own brain, think about all dependency of the system. DNS, DHCP is amazingly underestimated kind of problem. And secure browser, it's evolving. It's evolving in the terms that Google tried to do sandboxing of a session. Firefox as well is into that. Some got even exploited due to the sandboxing. There is a remote browser inclusion that is extremely young as a technology, but it does have a good potential. You need to rethink on the exposure of endpoint, also in terms of what get exploited. And so you need to have an approach also on understanding how a browser exploitation is going to impact everything you do. Back in the days, we had endpoint in terms of employee laptops, extremely based also on software. Now we are moving everything into API, into web application. So the browser is becoming your real first layer of touch, your untrusted domain, but is seated into your trusted domain. DOM is it can see your keyboard, can see everything you do. So pay attention to not buy marketing. You can go and follow whatever advice you want, but make your own using thinking. Invest on OS query or similar, Velociraptor, whatever you fancy. Invest in forensics. What's the point that we have so many data breach? We know that is the top risk, and there is zero investment in forensics. It's just silly. So I hope I gave you enough food for thought on how to structure an analysis of your endpoints. You'll find yourself in a situation where you do have for sure legacy system. Uh, let's avoid to talk about AIX specifically or whatever, but you can have legacy, gateway, structure, network segmentation are all part of a strategy. What I really dislike is when people talk about endpoint and think that everything need to happen in the endpoint by definition because there is no perimeter security. Yeah, but all CVE and all top attack of 2021 are about perimeter security, all VPN access, all load balancing stuff. And so think with your head. Don't just let somebody to set up your analysis. And OS query is quite good. It's if incident response wise, you can parse, do template, do queries and searches. For example, when there was the driver bypass, setting up query there was just blink of AI, and vendors struggle to look into that problem due to the callback, the kernel callback, and all other kind of stuff. But you could have been done really good filtering, just having the right tool. And the tool that I'm talking about costs you zero. I know that nothing costs zero because you need to implement it, you need it to support, but it's the thinking that is more important. You have endpoint, you have if it's an IoT, you have a gateway. If it's an endpoint in terms of laptop, you have an orchestrator. If it's a whatever device like a mobile, you can have an MDM. Focus on where is the higher point, where to tap and where to get everything. And think also on offline attacks. That's key. So, guys, there is another good article here, and if you want, I created a playlist. You look for Security Boutique on YouTube. You have a playlist with all lessons that I made so far, and as you see, I spent my best efforts to share my thinking and give you food for thought for your career. I hope you appreciate. As you see, it's all completely free. Subscribe and like the video. It will be appreciated. But subscribe to know when I publish new lesson, because I'm doing what I can to keep it regular, but I don't have a schedule that I follow. Okay, thanks a lot. Take care. Cheers.